Hey folks, welcome to the video on drawing board diagrams. Make sure you date your notes and put your name at the top. Oh no! Tara! Purpose. You don't have to write it in. I gave it to you. It's drawing board diagrams. So let's move on to the notes. The Bohr model. In the Bohr model, electrons occupy special positions called orbits, or energy levels around the nucleus. So if this is our nucleus here, we are going to have electrons here, and we're going to have electrons here, and electrons here, depending on the size of the atom. Sometimes this is called the planetary model because this nucleus is like our sun, and all of the planets in our solar system have orbits around the sun. Electrons occupy the closest orbital first. So here's the thing that I like to think about. The first orbit holds 2 electrons, and if we take our periodic table of elements, in the first period, or the first row of the periodic table of elements, we have 1 and we have 2 elements. So it makes sense then that the first would occupy 2, or 2 electrons would occupy it. The next one holds 8. So let's look at our periodic table again. In our second period, we have 1, 2, 3, 4, 5, 6, 7, 8. Cool. I love how science is like that. That's so great. In the third orbit, so just going back to our notes here, the third orbit also holds 8. Let's count how many electrons we have, or how many elements are in that period. So first period, second period, third period. 1, 2, 3, 4, 5, 6, 7, 8. There are 8. So we're only going to talk about the first the first 3 periods. However, how many electrons do you think the fourth orbit holds? Well, let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. And the fifth one would hold 18, and the sixth one would hold, well, it would hold 18 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 28, 29, 30, 31, 32, 33. Woo! There would be a lot more elements. Oh, actually, there's only 32 because that holds it. This is a kind of a holder. So it actually has 32, and it just goes up from there. So you can see why we're only going to be dealing with the first 3, because I'm going to make you draw like 18 dots. I don't think so. Well, I'll make you draw up to 18, but I won't make you draw more than 18. So the electrons in the outer orbit are called valence electrons. That's just a name. So here's our nucleus in the planetary model, and we have 2 electrons in our first energy level or orbit. In the second one we have 8, and in the third one we also have 8. The way that I like to remember it is 8 is great because it kind of rhymes. So 8 is great. If you want to get extra cool, you can say 8 is great. The way that the electrons are configured help to tell us how an element is going to chemically react. So something with a little less than 8 and something with maybe 1 electron, or 1 less than a full valence shell and 1 in its valence shell, are going to be highly reactive. So something like sodium chloride, and we'll draw it out. So how do we complete a Bohr diagram? Step number 1, determine the number of neutrons, protons, electrons in the atom. Draw the nucleus, label the number of protons and neutrons in the nucleus, and then add the orbits and fill with the appropriate number of electrons. Not hashtag of electrons, okay? Number of electrons. So let's look at nitrogen. So we're going to zoom in here and just specifically look at nitrogen, which is right here. So nitrogen has an atomic mass of 14, and it has an atomic number of 7. So we can go here, and we know that the number of protons is going to be 7 protons, because that's what the atomic number is. The number of neutrons is going to be determined by looking at that atomic mass, 14, and subtracting 7 from it. So it's 14 minus 7, which equals 7 neutrons. Number of electrons has to match the number of protons, so we say 7 electrons. So when we actually draw this thing, I'm just going to go in here, we're going to say that we have 7 protons, we have 7 neutrons, and the way that we would draw 7 electrons would be 1, 2, and remember to fill the first shell because there are 2 elements in the first period or first row of the periodic table. So we need to draw up to 7 though. So then we jump up to the next one and we go 1, 2, 3, 4, 5, 6, 7. And when you draw them like that, it's just really easy to count them when you draw them in pairs in the 8. Because if I am equally spacing 8 around my electron, it's harder to see. So this is much easier. Alright. So remember that atoms are identified with the number of protons in their nucleus. So you have to indicate that there are 9 protons in the nucleus. So let's look at fluorine, shall we? So fluorine has an atomic number of 9 and an atomic mass of 19. So we know that the number of protons is going to be 9 protons. The number of neutrons is going to be the atomic mass, which is 19, minus 9 protons, which is 10. So we have 10 neutrons. Number of electrons matches with the number of protons, so we know that we have 9 electrons. So I'm going to make this bigger and I'm going to say, okay, 9 protons, 10 neutrons, and I'm going to say 9 electrons. So 1, 2 to fill the first shell, because in the first period there are going to be 2 elements. So there are 2 electrons in the first orbit. And then I'm going to count up to 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Great! So we're noticing that there is only 1 more electron needed to fill that shell. That means that fluorine is actually pretty reactive. It's pretty reactive. So let's talk about drawing the Bohr model for sodium here. So I'm going to show you a different way because this one, let's look at sodium here. When we look here, sodium is actually in the 3rd period. So first period, 2nd period, 3rd period. So that means we have a lot more electrons to draw. So this will save you a little bit of time. We'll do it the old way first and then we'll do it the new way. So first of all, number of protons, number of neutrons, number of electrons. So we look at the atomic number of sodium, and we have 11. So the atomic number is 11. The atomic mass is 23. So I know that we have 11 protons. We have 11 electrons, because those two are the same in an atom because it must be neutral. The number of neutrons is going to be 23 because that's our atomic mass for sodium. 23 minus the number of protons minus 11 equals 12 neutrons. Okay, so I'm going to write in here the number of protons, P positive, 12 neutrons, and I'm going to go and draw in all of my electrons. So in the first orbit, I know I'm filled with 2. Now I need to move over to the next orbit. So 2, and then I'm going to say 3, 4, 5, 6, 7, 8, 9, 10. But wait, we need 11 electrons. Sorry, not protons. We need 11 electrons. So we need to spill over into the next orbit. So that's a lot of dots, if you ask me. So the quicker way of doing it is I still need to put the number of protons in the nucleus, still need to put the number of electrons in the nucleus. But what I can do is I can say, okay, so we have 2 electrons in the first orbit. I can literally write that. And then I have 8 electrons in the second orbit. And then in the third orbit, I'll just draw my only one. Because we need to have 11 electrons, so we have 2 plus 8 plus 1, which is 11. So if you prefer this one for bigger atoms, that's totally cool. That's a totally legitimate way of drawing it. If you like the way that this looks and maybe drawing dots is your thing, go for it. Keep on going with this one. That's totally fine. So, to summarize, we can say that to draw a Bohr diagram, 1, find number of protons, neutrons, and electrons. 2, the first orbit is filled with 2 electrons. Okay. 3, if you have more electrons, the next 2 orbits can hold 8 each. I'm also just going to remember the shortcut. And let me just reiterate, in the nucleus you must draw, or you must indicate how many protons and how many neutrons there are.